Welcome, everyone. Thanks for joining us today. I'm going to give you a tour of one of Enthought's professional development training courses. It's called Python for Scientists and Engineers. My name is Mike Connell. I'm Vice President of Training Solutions at Enthought. And today I'm going to spend just a little bit of time telling you who Enthought is and what we do, for those of you who might not be familiar with our work. I'll spend the bulk of the time giving you an overview and a little bit more of an in-depth insight into the Python for Scientists and Engineers class. And note that this isn't a training. I'm not going to be training you on Python. I'm going to be telling you about the training class. You may pick up a tip or two, but that's the primary focus, is what's the class about, who's it for, and so on. And then at the end, we'll answer your questions in Q&A. Note that we'll be responding to questions live, though, during the presentation. So if you have a question, feel free to type it into the questions box. And my colleague Courtney will respond to it if she can. Otherwise, she'll kind of batch those up, and we can handle the other one, any that are remaining at the end. And everyone who registered for this session will also receive a link to the recording. All right, so who is Enthought and what do we do? We do what we call scientific and analytic computing, and it's easier, I find, to give you a couple of case examples to start, and then I can tell you more generally what we do. So you can find these on our corporate website at enthought.com/services/consulting/case-studies. You can read more about these, and there are others from other industries as well. I selected just two cases that are, one's kind of a scientist application and one's more of an engineering application, because that fits best with the intended audience for this course, but we do it in other industries as well. And so this one is called the Microbiology Lab, and this was a project we did with Procter & Gamble. So what they do consumer packaged goods. They create shampoos and body lotions and so on. Those are new kinds of fluids. They're very complex, and they've never been invented before. So nobody knows, for example, what the viscosity of that fluid is. And they have scientists on staff, and part of their responsibility is to help figure that out. And viscosity matters because it determines how hard people have to squeeze the bottle or the tube to get the stuff out when they want to use it. So back in the old days, right, it took large setups with large quantities of this prototype fluid that they would put under large forces to figure out what the viscosity is. And these researchers at Harvard figured out that they could do it with a small amount of fluid more easily if you could just drop these kind of little traceable particles in there and then optically follow their paths and build up a distribution of their Brownian motion. And from that, they had a theory for how to translate that into the viscosity for the fluid under certain conditions. So we worked with their scientists. We went to the literature and figured out the models for the fluid and the models for how to translate that into the viscosity constant, and or viscosity parameter, I guess you could say. And so then we built this kind of application with them where they can set up their fluid sample, and then there's an optical scanner, so it's actually live looking at these particles, and then algorithms to track the particles and extract all the measurements. And that's typical of what we do. This is a new capability. This is not something that somebody could do with their naked eye. You have to have the technology. And it also speeds up the process. And it allows people who are more junior, let's say, to do it rather than having just a senior scientist at a lab bench who has to have all that knowledge in their head. So it really opens up new capabilities and makes things far more efficient. And you can see here in the interface that we've got a lot of different visualizations. We crafted those for what they precisely wanted in their workflows. And they can also at any point drop down to a command line, and all of the state that's shown in this interface is also available in the command prompt. And so they can go down there and they can do ad hoc analysis in the middle of any of these runs. So that's a kind of a science example where you're really kind of running experiments. This is more of an engineering example. Once they have a fluid that they know they want to manufacture, they need to set up a mixing tank and blades and pipes and motors and all of that to move it around and prepare it. And that's a complicated process, and you don't want to be doing it by trial and error, which you sort of have to if you don't have some way to kind of simulate. So we worked with them again to build a simulator where they could develop and test and optimize their setups for these kinds of production processes. So that's more of an engineering process. And in addition, with all the same benefits that I talked about before, They could also layer on kind of their expert knowledge. There might be things that are physically possible that don't lead to a good result, because they leave crust in the bottom of the container or something that builds up and causes problems. So you can layer on all of those alerts and special knowledge into the application as well. So that's what we call scientific and analytic computing, right? The purpose is not, the software is not the end goal. The software is in service of a scientific or engineering process or product. And Enthought has been a global leader in that kind of computing for over 15 years. Mostly we focus on Python. In more recent years, we've been doing a lot of work with artificial intelligence-enabled solutions in oil and gas, as well as manufacturing and aerospace, biotech, and others. We do a combination, so we do that kind of consulting that I just described, but we also provide a set of software tools, software that we've created for our own purposes, and now we make those available to you and to clients and to the public for kind of rapid application development of that sort that I just showed. We also do training, sometimes in conjunction with consulting. Sometimes people just want the training a la carte. And we provide enterprise support for Python. And you can kind of think of this as like Red Hat for Linux, right? Linux is open source. If you want to use it in the enterprise, you got to have somebody who's maintaining and building and testing it and all that. And Red Hat provided that enterprise support for Linux to corporations. We do the same thing for Python, which is also open source. We have a large user base. We've got over 1 million user downloads of our software products. And in terms of where we're located, we're headquartered in Austin, Texas in the US, and we have global reach with offices in Cambridge in the UK, as well as in India. All right, so let me just give you a little bit of sense of the different industries and things that we work in with the consulting. So we work a lot in energy and manufacturing and aero, a lot of biotech, consumer products, finance, and a whole range of other industries. Our consultants all have doctorates in relevant STEM fields, so we have a diverse of expertise just from their training and their other industry experience of applying Python there, but they're also able to rapidly go into a new domain and kind of read the literature and make sense of it in working with the scientists and engineers in that industry. So we're constantly working in new industries, which is exciting. Software and support, like I said, we've built a set of tools called, we've built a set of tools for our own purposes and for our customers. We have a Python distribution, which we build and test the scientific packages that people need. And then on top of that, we have a tools layer, and you'll see some of that as I go through the course materials. And then we, for writing applications and debugging them and installing your packages and so on. And then we have the Enthought deployment server for managing the distribution of your own software, plus a couple of plugins, one for Excel, one for LabVIEW, so that Python can talk to them. And we've done some big commercial software written in Python in the oil and gas industry. Mainly today, I want to talk about one of our training courses. So we do open classes where you can, as an individual, register, let's say, for a class in San Francisco in July or whatever, and then you would just go during those dates and attend with other people who registered that way. We also have corporate on-site courses where if you've got an intact team or two groups or something of people who need the same training, we can come on-site to your organization and deliver that for you at the dates that work best for you. Most of our training is in the United States, Canada, and Europe, but we have done training in the Far East, the Middle East, India, and other places. So we really do have global coverage there. All right, so you can see other webinars for these other courses, but I'm going to talk about this one today, Python for Scientists and Engineers. Customers sometimes ask us about our approach to training or our philosophy. My own background is in learning science. I studied robotics and artificial intelligence, as well as human learning and cognition. And so my interest has been in how do we extract principles from the learning science, from the research on brain and mind, and apply them to make more engaging and more effective learning experiences. So really our emphasis and our philosophy is all organized around the learning that you take away, and in particular the transferable skills that you'll take back to the job. So let me just give you a little flavor of that. So there's this trade-off between the scope of content and the depth of the learning. Sometimes people say, well, we need twice the learning, we want to double the content and we want to do it in fewer days. So the problem there is as you put more and more concepts into a fixed amount of time, like a day of training, let's say, you can teach 100 concepts at a very superficial level. But that kind of leaks away. People don't latch it very well, and they're not going to really be able to use it when they get back to work. Conversely, you could take just a handful of concepts in that same amount of time and teach them very deeply, right? You can develop skill, maybe even push beyond that to higher levels of like judgment and stuff like that. These are different kinds of knowledge, right? They're processed and stored in different parts of the brain, and they require a different kind of process for learning them, and they require different amounts of time. So we're very, very conscious of this trade-off between scope of learning and the depth of learning. And where we aim to what we aim to achieve is to leave people in our courses with transferable skills. The idea is you should get back to work on Monday morning and you should be able to apply what you learned without too much of a gap or having to go back and review too much stuff. And so part of that is, the depth here is concepts and skills are at a kind of a deeper level of knowledge than concepts, let's say. If you want a different kind of knowledge like skills, then you need to match the activity to the learning outcome that you want. So typically you'll see that our classes are 40 to 60% interactive. And that's because to build skills, you have to actually do that kind of activity. You can't learn, same way you can't learn to ride a bike by watching, a lecture. You can't learn to develop software that way either. All right, so these are the kinds of principles that we use to design our courses and make sure that we're hitting the mark. So let me tell you about the course itself. It's 5 days, and this so the prereqs for this class, you don't need any Python experience coming in. We'll teach you everything you need to know about Python. You should be comfortable, however, with general programming concepts, like what's a variable, what's a loop, what's a function. You should have been exposed to that in some language or some technology in the past. It could be a macro language, it could be Visual Basic or R or SAS or MATLAB or C or Java. It doesn't matter, but you should be comfortable with those basic programming concepts. In terms of audience, we have other courses that are for other audiences and workflows, but for this particular course, Python for Scientists and Engineers, it's the kind of people who do the kind of work that I showed you in those two case studies, right? People who are doing modeling and or analysis. The focus might be on repeatable processes, so it's not like a one and done where you throw away the code. It's something that you might actually be able to run 100 times or 1,000 times over years with variations, right? There's something similar, even though you might have to do some ad hoc analysis in the middle. So automated or semi-automated processes, and because of that, you might want to create simple graphical user interface tools to streamline the workflows, and also to make your applications available to people who don't know the programming language so that they can operate them. Maybe a junior person, right? So you can actually get more leverage there. And then often, maybe you've got like large libraries that are well validated, well tested, have a lot of good code in them for your simulations or analyses or whatever you're doing. And those are legacy libraries that are in C or C++ or some other language, and you want to interface with them from Python. We show you how to do that as well, because that's a common issue. And similar principles apply when you're interfacing with hardware. All right, so one of the subgroups of people who comes through this, we hear this a lot, is programming isn't really my job. I just have to do it every day. And that sort of speaks to the fact that they were trained as a scientist, they were trained as an engineer. The world has moved into the digital era, and so now often those kinds of people find themselves writing a lot of software. And a lot of the times that software actually becomes institutionalized. It becomes part of the code base that everybody builds on and uses, even if at the time they thought it was going to be kind of a throwaway. So they need to be thinking for the long term and thinking about how to craft that, craft those applications with that in mind. So we give the crash course in that for people who didn't study that but are doing a lot of it. We collect a lot of feedback from our participants. We have these intentions and goals for our designs, and we want to make sure that we're hitting the mark. So one way we do that is we solicit feedback from people. And I'll give you a couple of points at key parts of this presentation just to help understand how we're validating and how you can too. So one person said this course was wonderful, saved weeks, if not months, of the time associated in frustration of learning a new programming language, and feel prepared to use Python at work. So this says three things, right? One, they had a good experience. Two is that they found the value in the kind of time savings, but also that they didn't know the language. So it does work for people who don't know Python coming in, and the transferable knowledge is in that last bit, like they feel prepared to use it at work. So that's the kind of data that we use in part to validate that we're hitting the mark. And then here's somebody else who said they already knew Python. They had experience in Python, but they found it extremely useful in upping their game. So now they know how to fix the scripts that they've written and move forward with more best practices. So it works for quite a wide range of people. We actually find a lot of people coming in who know Python or think they know Python pretty well, and they find that there's just a lot to know beyond what keyword to use when and where to put the white space, right? There's just a lot to the craft of this, and there's a lot you can know about the internal workings of Python and how to make good choices about it that you may not pick up just by kind of, doing the work and learning that way. All right, let's look at the modules one by one. So the first one is the Python language, and it kind of has 4 units: the tools, the data structures, control flow, and organizing code. And really, data structures and control flow are the heart of any programming language. So let's talk about the tools first. So the kind of work that we're doing in analytic and scientific computing, right, engineering and so on, science, is different from typical software engineering. And so if you just get the interpreter, the Python interpreter for python.org, it's not optimized for that kind of work. It's optimized for other kinds of work, like scripting or IT or, maybe software engineering. So, what we need partly is we need more rapid access to the documentation on APIs because we're always looking up parameters to remind ourselves about these scientific APIs. And so that comes with the interactive Python shell called IPython. We provide that as part of the training tools that you get with the training. And the other thing is you can see that these are numbered over here on the left, 3, 4, 5, 6. So you can jump back and pull out an input or an output from a previous step without having to restart and build yourself back to that state. So it's got some really nice enhancements for this kind of work. So the command line is great for certain kinds of exploratory analysis and prototyping. If you're doing more kind of analysis to get to a result, the Jupyter Notebook is a great front end to the same interactive Python kernel. And this is really like Mathematica or Maple or some of those which have these notebooks where you can, inline, you can put text and you can intermix that with your code and you can intermix it with the outputs of intermediate steps so all of your graphs can be in there. It's really fantastic for repeatable science. If you want to archive how you got to a result, you want to share it so other people can get there, you want to make it a supplement to an article or whatever. It's really a fantastic tool for that. So we teach you how to use that. There's a script editor, of course. If you're doing any kind of software that's more than just analysis, it's a simulation or it's a repeatable workflow or anything like that, you need to be writing it in an editor and then submitting it to Python to execute. So Canopy ships with an editor, and we show you how to use that. One of the big deals is packages when you're using Python for scientific computing. So we have a graphical-based package manager that ships with Canopy. And if you don't like the command line, this is great for that, but it's just a great package manager. It handles all the dependencies. So you install a package and it makes sure all of the versions of all the other packages it depends on are installed. If you want to update it, it'll uninstall and reinstall the right dependencies, and it notifies you when there are updates and so on. So we talked about that. There's a debugger that comes with Python. It's a command line debugger. Canopy also has a graphical debugger. So we talked a bit about that. And then finally, we want you to walk away from the course knowing what we were teaching you, but we also want you to be able to walk away being able to learn more on your own and build on that. So we make sure that you're very comfortable with the help and documentation systems. So if you want, you can get the Canopy installation and get most of these tools for free right now. And well, not now, after the webinar. Enthought.com/products/Canopy, and you can get that and check it out. All right, so Python language, the data structures are the next big topic. There are a lot of data structures in Python. We don't try to cover all of them. Our goal is really, like I said, to get you to the most useful, compact set of knowledge that'll get you up and running quickly at a level of transferable skill. And one way we do that is we curate these topics very carefully. So, for example, we'll teach you the 6 data structure types that are most useful to most people 80% of the time, right? It's that 20% of material that's useful 80% of the time. So this is a typical lecture slide, and I just want to point out a few features of the design. One is, like I just said, it's not everything. We're not going to go exhaustively over every API and every parameter. We give you the 20% of stuff that most people use 80% of the time, so it's highly curated. It's example-based. We're not walking you through abstract APIs. We're actually giving you examples of each of these, functions and attributes, or methods and attributes. And so the example-based introduction is easier, I think, for people to get their head around. And the code's all executable as well. So when the instructor is giving the lecture, you can be typing along. You get engaged that way, but you also get to try stuff out. So better learning, and you may see something interesting or weird, and that generates a question. So we encourage the dialogue with the instructor throughout. So this is like the first level of design where we're trying to make sure that you're learning this and starting to develop the very lowest level kind of skill layer. And then finally, after the class, the manual serves as a concise reference, highly curated, and a set of code recipes that you can use for your own programs later. All right, so again, there are a lot of methods with lists. We don't give them all to you. We just give the curated set of the most useful. But we also kind of wind in here expert tips and tricks. Here's a method we're showing you. We're not showing you another one, but if you need a new list, this one sorts it in place. If you need a new list, we point you to another function that's similar, but it's slightly different. So always trying to kind of layer on as much of that expert knowledge as we can. So the next layer up from that is we have what we call these finger exercises. So frequently throughout the course, we'll teach you a concept like about lists, and then for 3 to 7 minutes, we'll have you use that, and you need to solve some problem. And so it's a little tiny exercise called a finger exercise, and those are really important to the learning because that's where you're starting to develop the skill and the application knowledge, which really helps you to remember it and remember it in a way that you can use it. And so the lectures I see really support the exercises. So they work kind of hand in glove like that. So in terms of the design, just as an example of feedback, one person said that this format of going back and forth between the lectures and the finger exercises, and then we have bigger and bigger exercises, 15 or 20-minute exercises, and then hour-long exercises sometimes. So we're building to more and more complex skills. This person found that extremely helpful to build foundational understanding, which is, of course, the goal. And it's a great way to know how to use the libraries. So that's the transferable knowledge, but also not to just do it cutting and pasting other code and tweaking it, but really understanding. And that's absolutely what we're after here. All right, control flow, every program has to do different things based on, one condition or another, and that's if-then statements. If you want to run something 1,000,000 times, you need loops, while loops and for loops, and then there are special Pythonic looping patterns like list comprehensions that you should know about. So we cover those. And then finally, if you don't have any training in software craftsmanship, a lot of people end up writing these big, crazy scripts, and 6 months later, heaven help you if you want to try and add to it or figure out what it does, you yourself who wrote it. So it's better to organize your code, and we show you how to use functions and modules as the first 2 tools in your toolkit for doing that. All right, so that's the Python language, and then the next layers up are the core scientific stack for Python. NumPy and Matplotlib are for fast array programming. That's NumPy, and Matplotlib is for visualization. So NumPy it allows you to do array programming, so you can kind of do A plus B, and those A and B might be scalar numbers or they might be arrays, and so it makes for nice, concise syntax. So we teach you about, get your head around the array programming paradigm, how to create them and interact with them and so on, and then compute with them, and then Matplotlib for visualization. Okay, so this is an example of a lecture slide where part of what we try to do throughout is really help you develop a mental model of what's going on, sometimes what's going on under the covers, right, in Python, so that if you have that grounding, a lot of things make a lot more sense. Otherwise, it's just kind of a bunch of mysterious, arbitrary design decisions that somebody made. But if you really understand kind of how this is implemented and how it's presented to the user, and that can really facilitate your understanding. So this is another lecture slide. Same point is that, once you understand that mental model, then when we're showing you the code, there's a place to kind of hang that knowledge. And then how do we use these arrays? And so we show you how to select out data and slice up the array. And you can see over here how concise the syntax is, right? This is the array, and you're really selecting out these very complicated patterns with just tiny little bits of code. And then here would be another example of a short finger exercise where we just showed you how to index this stuff, and now we want you to do it for yourself. Okay, so those are all throughout the course. Then we move into array calculation. You're going to do numerical operations, statistics, transformations, and then structural operations. Sometimes actually you can solve problems without doing any calculations just by restructuring, flattening your array, or reshaping it, or that kind of a thing. So that's NumPy, fast array programming, and it is implemented to be very, very efficient and fast. And then there's Matplotlib. That's the workhorse visualization package. And the first thing, this is another mental model, you need to understand the object model. What is a figure in Matplotlib? What are its parts, the axes? What are the parts of the axes, and so on? And once you understand that, things become a lot less mysterious. So then we'll walk you through how to create scatter plots and line plots and image plots and histograms and so on. And it's done again through, here's sample code, here's what it'll build for you, and you can not only kind of type along, but you can use that in your own programs later. And then this would be an example of a more substantial exercise where we've taught you maybe 8 concepts or so from Matplotlib, different types of plots, color bars, subplots, structure, all that. And now we say, okay, now take the next 20 minutes or so and create this plot. So that's a good example of a more synthetic exercise. And then some of them are even higher level where we would, do data structures and control flow and organizing code all in one bigger exercise. All right, so those are the core elements of the scientific stack. And then Pandas is just a workhorse. You can do loading of data, cleaning, preparation, wrangling, shaping, analysis. It's just a great package for doing a lot of different tasks. Similarly to what I did for the Python language, I'll just kind of talk about the data structures, the computation here, and then also it supports more wrangling and data manipulation. So I'm going to cover this part kind of quickly, skim over it a bit. So the Pandas data structures are the series and the data frames. Those are the ones we cover. Also, the index is new and important. One of the amazing things about Pandas is how great it handles input and output, a number of different file formats that it can read and write. Some people use it just for that. It's that useful. Instead of having to go and find a package for, an Excel file and a separate package for a CSV and so on, you can do it all right here. It has some really nice additional features above and beyond NumPy for dealing with missing data. So we talk about that. It's phenomenal for dates and times. Some industries like finance, that's more important than others, but where you need it because time zones are a nightmare. Time formats, date and time formats are a nightmare, leap years are a nightmare, and it just makes all of that very seamless. So we talk about that. And then, of course, everyone needs the computational and or statistical operations. And so we cover that. And then finally, another great thing about Pandas is that if you need, for example, to do an operation and you've got different subsets like men and women or different age groups or any attribute, you can, with one line, basically split it, apply the operation, and recombine it into a new data frame. And it's just so simple and powerful. You can also merge different data sets nicely and do things like pivoting. So that's the data manipulation section. If you're using Pandas or you're interested in what's covered in the course, you can go and get our Pandas cheat sheets. They're at enthought.com/pandas-mastery-workshop. And there are 8 of them, and they're really beautiful and really useful. And this is a superset of what's covered in the Python for Scientists and Engineers Pandas component, because this is for the Pandas Mastery Workshop, which is a bigger kind of Pandas course. All right, so that's the core stack, right? Python and the core scientific tools within Python. Then there are these more specialty tools for scientists and engineers that I've already alluded to. So one big area is software craftsmanship. We get requests for that all the time because people are writing code and it's being used by other people and themselves, and they know that they're not doing a great job with architecting it, but they don't know how to change that. So I already talked about two techniques that we introduced, like functions and modules as a way of organizing your code. A higher level is object-oriented programming, and we show you how to create classes and subclasses, and that's great for a lot of science and engineering applications because you have objects, right? I mean, if you're looking at a fluid and you're looking at a mixing tank and you're looking at a blade, each of those is an object in the real world, and it's got properties and it's got behaviors that it's capable of. And so you can write your programs that way that kind of mimic the real world, and then your thought processes that you use in your science, you can actually, in some ways, apply to the software and engineering. So that's great. It also really supports code reuse and accelerated development and maintenance and all that. So we give you an introduction to how to use that. And then we get into software craftsmanship, which you can kind of think of as the software engineering class that the scientist or engineer never had. You know, and like I was saying before, if you're just doing something that's a one-off, truly in a throwaway, you might do it in a command line, iterate and throw it away. If you're doing anything for production, you're building for the ages, and you need to think about that. And so there's a lot of other skills and disciplines that really need to be brought into the whole engineering process here. So one is documentation, right? There are best practices and there are tools in Python, and we introduce you to those. Another is coding standards, right? How you name your variables, how you name your classes, how you name your functions, how you use white space. If you adhere to the standards, not only does it help you, but it's standard, so other people can make sense of your code just as easily. Refactoring, there's this idea that you know, you're writing your code and then you've got a function that does 14 things, and that's not going to be understandable to anyone else or to you later. And so there are these disciplines which people have developed and what do you want to call them, principles that really help you to make code that's more maintainable, easier to understand, debug, reuse, modify, and test. For example, just to give you one, if each function represents one concept in our human mental space, that's a much more manageable state of affairs than having a few functions that have very complicated logic and do a whole bunch of different things. Those become completely opaque and very hard for people to work with. And also, when you have a bug, it's it's a huge ordeal to try and figure out where it is and what's gone wrong. All right, so testing code, right? There are, again, disciplines as well as tools in Python, and we introduce you to some of those. Monitoring execution, if you're running a long process that's running all the time, nobody's watching it. If it crashes, you want to know where it crashed and what the state of it was. You also might want to monitor whether things are becoming corrupted, the data and so on passing through it, or it's still clean at various points. And so you can log your data into log files, and we show you how to do that. Debugging is actually, again, there's a set of tools, and people think of the debugger as debugging, but really it's a set of disciplines too. The first thing is to write code that's easy to understand. Actually, that's a debugging sort of technique. The second is to check the documentation to make sure that you're using it right, and in fact that what it does is what the documentation says. The third is to monitor the execution to see if it's doing anything weird or wrong, because not every bug causes a crash, right? It could be a logical bug. And then finally, if you're having problems with your code and none of these solve it, then you may need to bring in a debugger. And so we show you how to use the debugger, but we also talk about these best practices and these disciplines around debugging and creating debuggable code. And then finally, there's profiling, right? You don't want to optimize every line of code for two reasons. One, it takes a lot of time that may be wasted. And two, often when you have to optimize a piece of code, you have to make it much more dense and complex. It's kind of a trade-off that you're making between readability and efficiency. And so the best practice here is to profile your code. Write it, write it cleanly and maintainably, and then profile it and see where the bottlenecks are. And if you've got a real hotspot, then you can go in and you can really optimize that one and deal with it especially, but in a much more surgical way. All right, so that's software craftsmanship, really valuable techniques and tools for everybody to know. All right, the next thing is, like I said, interfacing with other languages. There are a number of uses for this. One is you've got legacy code and you want to use it, but you want to use it with the flexibility of Python, which is easier for people to get their head around, and in some ways just a much more pleasant language to use, much more efficient. You may have bits of code in different libraries, Perl constants and C++ simulation libraries and so on, and you want to use one interface, one language to rule them all and to kind of get them under control. So Python can become your programming language, and then all of those can be kind of wrapped, and you can use them. And then the other one is for performance. In some, Python's fine for most parts of most applications, but sometimes you've got real time or some kind of speed critical component or algorithm, and you really want to speed it up. Well, you can use Python or something like that to basically have it compile to C, and then you can run it again from your Python. So these are all different techniques, and we do wrapping C code by hand so that Python can access it, or you can create a DLL in C or C++ and then export that so that you can access the functionality in there, and then Python is for speeding stuff up. All right, so those are common use cases, and we show you some of the key technologies that Python provides for handling that problem. All right, and then the final section here is building graphical user interface elements, and we at Enthought have developed a whole stack of technologies that we call the Enthought tool suite, which we use in our own consulting and our own internal work, and it's amazing for accelerating the development process. So really, Traits and Traits UI, that's a library of you can think of it as a library of windowing widgets, buttons and sliders and so on that are attached to variables in the code very tightly. So it's kind of reactive programming where if I change the value of a variable and it's a Traits UI enabled variable, then the value in the slider that it represents changes. And if I change the slider, the variable underlying it changes. And so you kind of have this nice ability. It's what affords the ability, basically, in those applications I showed before, to be doing your semi-automated process and then say, hey, that looks weird, drop down and start doing ad hoc analysis. Because all of the state that's represented in the user interface that you can see when you're doing it there is available to you now in the command line because of this tight binding. So it's very, very interesting and powerful. And then Chaco allows you to do 2D interactive plots, and Mojave is for 3D. Let me show you those real quickly. This is a traits application, and first I'll show it to you, and then I'll kind of mention something about the code. Okay, so this is a forest fire simulation, and we here have a slider for trees, and there's a variable, a traits-enabled variable underneath, and as I slide this, its value is changing. Okay, and then I've got some outputs here that I can trace what's going on. I've got a button where I can take steps. So each step, I'm growing trees in this forest. That's what this is. Okay, so they get more and more dense. I can run it automated. And then I can introduce fires at some point. So forest fires at some frequency, lightning strikes, let's say. And as they get more frequent and as the trees get more dense because they're growing faster, we get more fires. So this is a kind of a full-featured simulation app. And you've got outputs, and you've got intermediate outputs, and you've got a visualization of the agents in the model. It's really, the heart of this thing is less than 200 lines of code. And it's not complicated code. It's mostly kind of object-oriented, and it's using NumPy for the array calculations and the representation of the forest and the fires. It's just amazing. And I mean, you get all the GUI and all of the binding between the GUI and the underlying code with just a small number of lines of code. Here's an example of Chaco. So 2D representation, right? You can do those, of course, in lots of packages. But let's say that I actually want to look at just a cluster of particles here. This might be a fluid with some substructure in it. And I want to look at the regression in just that set, or maybe I want to look at the regression in this set. So you can do this interactive computing visualization, and Chaco provides a library of components and capabilities that allow you to create those rapidly. So there's a really short program. I mean, the heart of it is really this create plot component, 20 lines of code right here, and then there's, of course, creating the view and, and so on. There's some boilerplate stuff, but really 20 lines of code to get that functionality. And then this is Mojave. It's similar, but for 3D. Quite a powerful tool, and again, we use this in our consulting. You'll see it in some of our applications. So you can kind of do fun things. You could link these so that I could, let's say this is a CAT scan or an MRI or a slice of geospace, for oil and gas. I could pick what planes do I want to look at, and they might be represented over here. So I can really explore this. I could tilt them. I can do all kinds of stuff here. So, and you can link these and create all sorts of pipelines and then add parameters. So you could change some parameter and this whole volume would change to a different section or to a different coloring or whatever. Really, really powerful. And, tiny, tiny number of lines of code for that. Just, I mean, if we don't take the boilerplate stuff, we're looking at less than 50 lines of code here. So those are that's really the GUI technologies that we teach in the class. All right, so just a note on our trainers. So here's a comment that speaks to that, right? Highly recommend if you want to learn or improve your Python. Trainer was the best I've ever encountered. We actually see this quite a bit. Our trainers are deep Python experts. They all have experience in applying Python for these kinds of applications. So it's not academic, it's real world experience. And then they are very passionate about the teaching. I mean, they're constantly looking for ways to just make it better and better. And it shows, right? Every trainer to date has had a PhD in some relevant domain, just world class. Another comment on the overall kind of transferability. I didn't know anything about Python before the class, and now it's one of my primary languages. So just really, again, reinforcing that we're getting the transferable knowledge. And then overall, we see this kind of comment too. This is a rocket scientist actually at NASA. Best training class I've ever had in 17 years working at NASA. So we really work hard to make these the best they can be and to make sure that you're getting the value out of them that you came for. And more than 95% of people say they would recommend it to colleagues. So we have a very high satisfaction rating. All right, just really quickly, some of our training clients, so you can kind of see the industries. We do a lot of finance. We do a lot of oil and gas, aerospace, social media, consumer packaged goods, electronics, a lot of military stuff, biotech, national labs, consumer electronics again. So just a wide range of fields. And these are training customers, and these tools are very general, so they apply across all kinds of industries. All right, so if you're somebody who's interested in this kind of training and you're an individual, you should go look at our open calendar at enthought.com/training and see what dates and locations are best suited to what you need. We have other classes as well that might be a good fit for some people. This is the dates for the Python for scientists and engineers. And if you want to request a different location and you think you've got a group of 6 or 7 people where you are, give us a shout. Go to enthought.com/training and contact us through the form and let us know where you are and that you've got these people, and we can try and set up an open course where you are. If you have a group, you're in an organization or a company, and you want your team trained or a couple of teams or whatever, you should talk to one of our account executives, Brian Allison and Michael Millett. You can reach them via email at info@enthought.com or enthought.com/contact. There's a form there, or at this phone number, just ask for one of them, Brian Allison and Michael Millett, and they can guide you to the best fit, and we can figure out dates and logistics and all of that when you're ready to go forward. All right, just a quick thing. We're going to give you a quick survey after this. It would be really helpful if you could fill that out. We constantly want to make sure that what we're providing is what is most useful to folks, and so give us that feedback, and we will continue to try and improve our game. So now we've got some time for Q&A.
Hi, Mike. Well, we've gotten to a lot of the questions here today, but I did have 2 that I wanted to pose to you kind of for your expertise here. So at the beginning of the webinar, you were talking about depth versus scope and what the trade-offs are between the two. And there were some additional questions on that in terms of what is the ideal and have there been studies done on that? Can you speak a little bit more to that?
Oh, sure. So what's interesting is that that's kind of an engineering challenge in and of itself, right? You design the course for the purpose, so, and the audience and all of that and their prior knowledge. So there are a lot of variables that you have to take into account. So there's no sort of right answer there. It's actually useful sometimes to have a very broad survey course. Usually that's if you have a broad audience and and they need to know the landscape and they don't know where they're going to dig in, and different people might want to drill down in different places. So it's very, very useful for that purpose. But for this kind of a course specifically, we know that people are coming here because they want to develop a new capability, and so you can't really develop deep judgment in a week. And so that's why we've settled on transferable knowledge as kind of the minimum that people need, and so that's how we balance out, is we want to give them as much of the relevant content for what they need in the shortest amount of time, but at a level of depth that is definitely they're going to be able to apply. And that's why I pulled some of those specific quotes to show that does seem to be happening for people as they walk back to work and they have that new capability. So that's what we found is most useful to people for this particular kind of course in this domain. But it does vary. It depends on, an apprenticeship, for example, might last 3 years, and that's more to build deep expertise down to the level of judgment. So there are different design requirements for different courses, and we have to take that into account.
Okay, great. That's helpful. Another question we had is whether this would be an appropriate course or a helpful course for somebody coming over from MATLAB.
Oh, absolutely. We see a lot of folks who've had MATLAB in college or are using it in their work, and Python's got an amazing tool set as well as being open source, so that's got some advantages. Yeah, so some of like Matplotlib, some of the syntax will be familiar to people who know MATLAB, so there's a nice bridge there You can really leverage some of what you already know. The array programming paradigm will be familiar from MATLAB that is in NumPy. So this course is great for people who know MATLAB. We don't need to make any adjustments to it because if it's a group of people who know MATLAB, the instructor can simply detect that they're moving more quickly through certain parts because of that and will adapt the pace accordingly. That's one thing I didn't mention, is that part of having all these little finger exercises is to latch the knowledge and to develop the skill, but also so the instructor has visible information about how to pace the course and who needs help when and so on. So it really makes the learning visible and they can do that much better. But yeah, so MATLAB is a great fit. And in fact, we'll be having another webinar, I think in September, where we'll talk specifically about MATLAB to Python transition or migration.
Mike, actually, on a similar note, someone would also like to know how Python compares as an alternative to Mathematica. What they're specifically working in Mathematica is things like linear algebra, FFTs, and other basic data processing. So with those items in mind, what are your thoughts on that?
Yeah, so I think, so Python is a great language because it fits your brain, people say. It's designed in a way to be sort of easier to learn, easier to use. It's also, I've seen comparisons where you could do in 400 lines of code in Python what would take, thousands or tens of thousands of lines of code to do in another language like C or C++. So it's a nice language that way. I've done some in Mathematica, but not a lot. It very much depends on what you're doing and what libraries you need. For FFTs, for linear algebra, Python has terrific support for that. So if the scope is kind of well covered by the libraries that Python provides, then it's definitely worth a try, because it also, typically what happens is if people are using more of a specialized tool like Mathematica, it's great for what it does, but then they hit these barriers. They might want to automate, or they might want to do some object-oriented programming, or they might want to interface with another language, and it's kind of, if it has any support for that sort of thing, it's poor. So it's not really a full-blown programming environment. Python is. So if there's anything you're feeling a little bit closed in, then you definitely should check it out. And if that's kind of the kind of thing you're using, there's amazing packages for those kinds of operations in linear algebra and FFTs, and plus a whole lot more. That is a critical thing, though, is you'll want to check. You'll want to check whether the list of kinds of mathematical operations and transformations and things you're doing, whether they are completely covered in Python or not.
Well, this is a popular line of questioning. We've got a few more coming in that are similar to that. Related to what you were just saying, someone was asking if it's possible to convert Python code into executables. So would you answer that one, please?
So interpretable. So Python is an interpreted language. That's a good question. I don't know the answer to that. I don't like the Java JIT compiler or something. I don't know about that. Python is a kind of a compiler that takes, well, there are some tools for kind of doing that in part, but I don't know the answer to that. I don't know the answer to that so well. We could give, though, if you want to give us your email address, you can email it to us, and I could ask one of the engineers.
Okay, nope, sounds good. And then I think one final question, kind of on a language comparison basis. This question was Python compared to Java for this particular purpose.
For which particular? For like this kind of data analysis and stuff, or engineering, science? For
science and engineering, yes.
Yeah, yeah. I think we see a lot of people, a lot of Java programmers. It's kind of funny, right? Because Java really, in a way, conditions you, let's say, into a particular paradigm. Everything's an object. And so coming to Python is both liberating, and for some people, they feel like it's a little bit too under-constrained because Python supports, scripting and functional programming and declarative programming and object-oriented programming, and you can mix that right in the same script if you want to. So you need to be thoughtful about how you're writing your programs, but it provides an incredible amount of flexibility, and that brings power. So I think you should look into it, because I think for the problem is, it sort of depends on your workflow, but the problem with a lot of this is that the work is kind of a combination of I need to do something that I need to run once, but I also need to then interact with it at different points. And I think Java is not great for that. And then also for developing new programs, Java is one of those that would take 10 times as much code to do what you could do in Python with a fraction of that code. So it's definitely worth looking into. Again, things depend on the details of your organization and your tool stack and your culture and all those things. But Python, I think, I would say on the whole, my estimation would be that for most applications, Python is a much better tool set than Java for this kind of work.
Okay, and I should have known we were leaving at least one out here. So now actually a similar question on R. This one specifically, Matthew is asking, how does the efficiency of loops in Python compare to R, which is classically inefficient? So how is the overall efficiency of Python? So maybe if you could answer that, and then also, since we're talking about Python compared to other languages, give a quick synopsis of Python and R.
Yeah, sure. So Python's more comprehensive than R. I think R has sort of retrofitted object-oriented programming, for example, but it's not great. Python's got it built in natively. R has, I think, some more specialized libraries, and they're somewhat esoteric. So I don't think there are big gaps in the main libraries that people use, like linear algebra and FFTs. That's all covered fine. Optimization, minimization, Python's great there. Some of your more esoteric kinds of models and things you might have in R and not yet in Python, although we're constantly getting new contributions there. So the data frame is very similar to the data frame in Pandas. Pandas is actually modeled on R, so that's all great. So when you're talking about loops, there are some, like list comprehensions are kind of an efficient way to do loops. And then a lot of the time, if you can replace a loop, if you can replace a loop with an array computation, which sometimes you can, or a lot of times you can, then NumPy is very, very fast. I don't actually know how the numbers compare to R calculations that way. And I also honestly I don't know how the looping compares, but I do know that one of Python's great strengths, again, is that that's one area. If you've got some loops that are kind of in a critical bottleneck spot, you can always compile that down to C in a very straightforward way using something like Python. And so you can get the performance that you need in those particular places without creating huge complexity in your code. And I don't believe that R supports that kind of flexibility and interoperability nearly well.
Okay, and then one final question, and then we will cut off here. So I've got a couple of questions about whether this course has any content on either artificial intelligence, AI, or machine learning. Could you speak to that as well, please? Sure.
So this course does not. Like I said, we've got a number of courses. One of them is called Python for Data Science, and that one is one you want to look at if this is the set of topics that interests you. There we cover topics that are more relevant to people doing that work, like there's some database access, there's some more visualization, there's machine learning techniques for regression and classification, and then if time permits, which often it doesn't because it's a pretty intense course, there's some natural language processing material that we cover. So yeah, that would be in that course, but we don't cover any of that in this course.
Okay, very good. And I'm sorry, we have one more sneak in here on the language comparisons. What about Python alongside or instead of SPSS-like software? SPSS or probably SAS as well.
Yeah. So I've had my own experience with that, which I'll, I guess, share with you. So let me think for a sec. So it's got comprehensive coverage, let's say. There's a lot of packages in Python. It's open source, so you're not getting kind of the same, here's my dashboard, here's all my drop-down functions in the menus. If that appeals to you and is important to you, then that's something to consider. I found once, for example, that I had to write my own algorithm for something that I was doing in SPSS, and I couldn't find in Python. It wasn't complicated. I did it, and it worked just fine. and I was able to actually compare it to SPSS to make sure that everything was working right. So I would say that for what SPSS does, for that particular workflow, that's a very specialized tool. If that's all you need and you're comfortable with it, then great. If you need to expand at all, if you need to write code around it, you need to automate it, you need to embed it, you need to do some other kinds of analyses that are not whatever SPS, the scope of things that SPSS supports, like you need to do minimization, optimization, other kinds of modeling, machine learning, anything else, that's not covered in that toolbox, then you're going to start getting into the world where you're either going to be using two tools, and that's kind of a nightmare, or you'll want to shift to something like Python where you can kind of do all of it in one place. But Python's got great support for things like regression and correlations and rolling statistics and stuff like that. So, and Pandas actually make some of these super easy, some of the more standard kinds of things. As stats models does too. So yeah, I would look into it because Python's great. The big shift for some people is you're moving from more of a graphical interface to more of a kind of a command line environment. But once you get comfortable with Python's command line environment, the IPython prompt, that becomes kind of second nature. There just might be a little bit of a learning curve.
Well, Mike, thank you so much for being so knowledgeable and for commenting on those broad range of languages that we've got other people using. So with that, we're going to conclude the webinar for today. As Mike mentioned before, if you could take just a minute and fill out a couple quick questions on a survey about the webinar and any suggestions you might have for this class, we'd certainly appreciate it. And I hope you have a wonderful rest of your day. Thank you very much. Bye-bye.
Thanks, everyone. Bye-bye.